Welcome to Ask and Learn.
We are given sets of strings, and we are asked to determine whether the string 01001 is in each of the sets. In part A, we're given a set which is the clean closure of the set containing 0 and 1. We know that this set is going to contain any sequence of zeros and ones. In other words, this contains all bit strings, so it follows, since 01001 is a bit string, 01001 lies in the set. In part B, we're given the set which is the concatenation of the clean closure of the set containing 0, the closure of the set containing 10, and the set containing 10 and the clean closure of the set containing 1. So we know that the clean closure of 1 contains any sequence of 1s, and the clean closure of 0 is going to contain any sequence of 0s. So it follows that this set contains strings of any sequence of 0s, followed by 10, followed by any sequence of 1s, however, this implies that 01001 This implies that 01001 is not contained in this set because we have a 0 followed by a 10, but then followed by a 01, and 01 does not contain only 1s. In part C, we are given the set which is the concatenation of the clean closure of 010 and the clean closure of the set containing 0 and the set containing 1. So we know that the clean closure of the set containing 0 contains any sequence, or 0 and 1, 0 I mean, contains any sequence of 010s, and the clean closure of set containing 0 contains any sequence of zeros. So it follows that the set contains a string with any sequence of 0, 1, 0, followed by any sequence of 0, followed by a 1, so this means that the set does contain the bit string 0, 1, 0, 0, 1, since 0, 1, 0, 0, 1 starts with 0, 1, 0, followed by 0, and then followed by 1. In part D, we are given the set, which is the concatenation of the sets containing 0, 1, 0, 0, 1, 1, and the set containing 0, 0, 0, 1. So we have that this concatenation is going to contain all strings of the form xy, where x is a string in the set containing 0, 1, 0, 0, 1, 1, and y is a string in 0, 0, 0, 1. And so we see that this is going to contain the strings if x is 0, 1, 0, and y is 0, 0, 0, 1, 0, 0, 0. If x is 0, 1, 0, and y is 0, 1, 0, 1, 0, 0, 1. X is 0, 1, 1, and y is 0, 0, 0, 1, 1, 0, 0. And if x is 0, 1, 1, and y is 0, 1, 0, 1, 1, 0, 1. And so it follows that 0, 1, 0, 0, 1 is going to be contained in this set. It's the second string here. Now in part E, we're given the set, which is the concatenation of the set containing 0, 0, and the clean closure of the set containing 0 and the set containing 0, 1. Now, we know that the clean closure of the set containing 0 contains any sequence of zeros, so it follows that this set contains a string starting with 0, 0, followed by any sequence of zeros,
followed by a 0, 1, and so it follows that the set contains a string starting with 2 zeros, followed by any sequence of zeros and ending with 0, 1. This means that the set does not contain a bit string 0, 0, 1, 0, 1, because 0, 0, 1, 0, 1 contains multiple ones, and a string in the set can contain only one 1. Finally, in part F, we're given a set which is the concatenation of the clean closure of the set containing 0, 1 with the clean closure of the set containing 0, 1. So we know that by definition, clean closure of the set containing 0, 1 is going to contain a sequence of 0, 1s. So it follows that the set contains a string of any sequence of 0, 1s. So this means that this set does not contain a bit string 0, 1, 1, 0, 1, since if it were, then it would have to contain the same number of zeros and ones. But in fact, it has 2 zeros and 3 ones. So have it 0, 1, 0, 0, 1. This is a mistake. This should be 0, 1, 0, 0, 1.